Hello everyone. Can you hear me? Please let me know if you can hear me. I'm looking in the live chat. Hello, Aniket. Awesome. So I'll get started without any delay then. Awesome. So hello everyone. My name is Sai Avinash, and in this lecture series, I'll be covering dynamic programming problems from the Atcoder Educational DP contest series. If you're beginning with competitive programming, this is going to be really useful to you because dynamic programming is one of the important topics, being like that appear in a lot of competitive programming contests. And it also improves a lot of your problem solving skills as well, and in terms of thinking recursively and so on. And in this lecture class, I'd be solving the problem: what is the longest path in a directed acyclic graph? All right, awesome. So the things that you need here is like basic what are vectors and so on. What are vectors and basic C++, not a lot of it. And you don't need to know what the shortest path algorithm is. If you know, it's fine. Like you don't need to know a lot of graph algorithms. No, you don't need to know a lot of it actually. I'll teach whatever is required for you here. All right. Awesome. So who am I? I'm a SRE at Google Dublin. My name is Sai Avinash. Sorry, I should have said that first. I'm an All-India rank 4 in CodeChef. I'm red and 7-star there. I'm a Max International Master at Codeforces. Currently a master there, and previously interned at Uber, and I'm a Snackdown finalist. The subjects that I take are discrete maths, dynamic programming, graphs, and a lot of other competitive programming topics. Use the code SciLife to get 10% off on the Unacademy Pro subscription. All right, awesome. Let's get started then. So, what do we have here? The Career as a Software Developer subscription. It contains interesting shows covering a variety of topics. It shows around live problem solving at just $9.99 per year. So people enthusiasts in the software and technology domain who want to enable lifelong learning, this is the right course for them. Like if you want to be aware of the latest CS fundamentals and so on, this is the absolute right course for you. All right, and it's just $9.99 per year. Don't forget to use the code SciLife to get 10% off on the Unacademy Pro subscription. Awesome. So every Friday night we have college projects by Raj Vikramaditya Schreiber, and in this course he will be telling you what you need to improve in your college projects and what's missing from it and so on. It's a part of Unacademy's Career as a Software Developer subscription, and if you're in your college and if you're looking to work on good projects, this is the right, you could check this out for you. It's a part of Unacademy's Career as a Developer subscription. It's only $9.99 per year. So we have the Coach of Apprentice. It's a show every Saturday afternoon at 2 p.m. It starts at 14th August. And in this, as I've mentioned it before, I'd be mentoring a student who's mentoring any person that, for that matter, who's just started with competitive programming. Depending on what he's preparing for, I would guide them throughout the course, like throughout the 1 hour session. I would help them I would try to resolve their blockers and try to solve a couple of problems that they've been stuck with, and I would be explaining it to them. So if you're a competitive programmer who's just started with CP again, and you might find the blockers relatable, and do check it out if you think it's going to be useful for you. So here's a Telegram channel. It contains live update, like it updates you with the live up-to-date classes. So yeah, so that you don't miss out on any of them. So do share it with your friends if you think it's going to be useful for them, and You can wait till the end of the class, and if you find it useful, drop a like at the end of the class. It's fine. And don't forget to subscribe if you don't want to miss out on any of the content here. Awesome. So I'll get started then. Longest path in a DAG. Longest path in a DAG. What's the question here? What's the question? What's the question here? Longest path in a DAG. There is a directed graph G with n vertices and m edges. The vertices are numbered 1 to n, and for each I, the ith directed edge goes from vertex xi to yi. G does not contain any directed cycles. Find the length of the longest directed path in G. Here the length of a directed path is the number of edges in it. Alright. Awesome. 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 And the constraints are n is up to 10 power 5, m is up to 10 power 5. And what do we have here? Xi and y, the edges. All pairs xi and y are distinct, and it does not contain any directed cycles. Awesome. It can contain cycles, but they're just not directed. That's it. Awesome. Awesome. So let's first discuss. What a graph like. I know most of you must be knowing what a graph is. So let's first discuss how to like approach the problem first. Okay. Awesome. So what do we have here? Okay, this is the recipe from last problem. So what do we have here? Longest path. So first of all, we have what's a graph first. A graph is represented simply by nodes and edges. Nodes and edges. Edges represent the relationship between the nodes. For example, this is a graph. This is a graph. I'll just do a rough review of it. And sometimes, a lot of times, nodes are numbered 1, 2, 3, 4. And here the edges are simply the edges here. So there are 4 edges in the graph, and there are 4 vertices as well. The vertices are 1, 2, 3, 4. The edges are 1, 2, 2, 3, 1, 3, and 3, 4. Right. This is a graph. This is a graph. This is a graph where edges are not directed. There is no arrow over here. Like it's a bidirectional graph. So this is called a bidirectional graph. For those who just joined, this is the question: longest path in a DAG. Longest path in a directed acyclic graph. But I'm just explaining what a graph is now for people who don't know. All right. A graph is basically a bunch of edges, right? Nodes and edges. Nodes and edges. This is also a graph. A graph with no edges is also 2 nodes and no edges, 1 and 2. This is also a graph. So there are multiple graphs. So how do you like represent it? So one way is just like, for example, you have 1, 2, 3, 4, 5. Now the nodes are basically 1 to 5, right? Numbers 1 to 5. You can represent the nodes from 1 to 5. The edges are 1 to 2. We can call them pairs: 1, 2, 2, 3, 3, 5, 2, 5, 2, 4. There are 5 edges, and we can call them by pairs. All right. Now, some of the common applications include iterating through the graph, given a starting node. Given node 1, how do you find all the adjacent nodes? That's one of the applications. I'll tell you why later. All right. And this is an undirected graph. The edges are not directed. In some graphs, edges are directed. Right? Awesome. In this question, the edges are directed. Give me a minute. In this question, the vertices are numbered from 1 to n. ith directed edge goes from vertex xi to yi, xi to yi. All right. In this question, it's a directed graph, meaning there are arrows to edges. That means you can go from 2 to 3, but you cannot go from 3 to 2. There are 3 to 4, 3 to 5. It's a directed graph. You can't go the other way unless there's an edge. Unless there's a reverse edge, you cannot go another way, any other way. All right. You can only go in the direction of the edge. The edges are directed here. All right. Awesome. That means when you're specifying the edges, 1 to 2, we need to, the order matters here. What comes first matters here. In the input, when they say 1, 2, it means 1 to 2, depending on how the input is defined. 1 to 2, 2 to 3. 2 to 3 is not same as 3 to 2 here. Whereas in the undirected case, it was the same. All right. Awesome. 3 to 5, 3 to 5, 2 to 5, 2 to 5. We can't write this as 5, 2. No, we can't write this as this. 2 to 4. Oh, sorry, this is 3 to 4. Sorry, 3 to 4. As I said, again, we can't write this as 4, 3 because it's a directed case. If it was undirected, we could have written, but this is, since it's directed, we are not writing it as that. Okay. All right. Now, how does a directed graph look? It looks exactly as an undirected graph, but with arrows, right? Undirected graph, but with arrows. Awesome. So, an example of a directed graph would be maybe this could be an undirected graph. This could be a directed graph, whereas this is an undirected graph. Note that a single node is also a directed graph because there are no edges, which means all the edges that are there are directed. That statement is true, right? Because I mean no edges, so it's true. Like it's as if you're saying like well, you can say all numbers that are all natural numbers that are less than all positive numbers that are less than 0 are real numbers. Like it's basically false implies true. Yeah. All right. Awesome. Okay. Apologies for the analogy, but like I hope you get the idea. Empty nodes are also directed acyclic graphs. Awesome. Okay, there are many cases. Fine. Now, what is the question? They want you to find the longest path in the directed acyclic graph. They also mentioned another condition where there are no cycles here. What's a cycle? In an undirected graph, a cycle is this. Take any graph. In this, there are no cycles, but if you draw some edge like this is a cycle. Cycle, like if you can go on a path and again come back to the same point, that's a cycle here. If you draw this path, if there's an edge over here, then this is a cycle. Awesome. In this question, they said that there are no directed cycles. There could be undirected cycles, meaning the graph is somewhat like this. There are no cycles here. There are no cycles at all. Now you might say that there is a cycle. You might say there is a cycle, but there is no directed cycle as such because the arrows here, the arrows here, the arrows here. Directed cycle means it should be like this, something like this, meaning you can go from here, here, and reach the same point again. You're not finding that case here. You're going here down, but you can't go back because the arrow is directed here. All right. Awesome. Now the question asks you to find the longest path. Let's take an example what the question means. Longest path. Longest path. So say you have this, what do you say, directed acyclic graph. Awesome. Note that this is a directed acyclic graph. There are no cycles here. You might ask, isn't this a cycle? Isn't this a cycle? No, it's not. This is how it looks. Now you tell me, is it a cycle? Cycle should be like this. This is not a cycle. All right. Awesome. Awesome. So this is a directed acyclic graph. Now, how does a what do you say? How does a path look? How does a path look? Now, a path starts from here. Now, a path starts from here and it has to go to one of these vertices, right? Because they are the adjacent vertices and that's where you can go to. So the longest path from here would simply be 1 plus. Okay, first let's define what the longest path here is, like in this graph is. The longest path starting from here is simply 1. Actually 0. You can't traverse. Path is the length of the path is basically the number of edges that you traverse. So Dheeraj is asking, जब कोड करना स्टार्ट करता हूँ तब सारे कॉन्सेप्ट भूल जाता हूँ और मैं जब क्वेश्चन प्रैक्टिस करता हूँ लीड कोड या हैकर रैंक पे तो हद तक क्वेश्चन भाई समझ नहीं आते, क्या करूँ प्लीज हेल्प. ओके धीरज, how many months have you been practicing for? Like, just asking. Can you write that in the chat? Aniket, can the problem solve with standard Bellman-Ford approach? It could be solved. Like, you can multiply all the weights by -1, and since there are no negative cycles, it can be solved by Bellman-Ford approach. But the complexity of that would be more than what I'm going to show you now. The complexity that I'm going to show you is going to be much simpler. DAG is actually can be like a tree, not binary, I mean hierarchical. No. In a tree, this is not a tree. This is a tree. A DAG can be a tree, but all directed trees can be DAGs, but not all DAGs can be trees. This is a tree and a DAG, but if you draw this edge, this is a DAG, but it's not a tree because there's a there are 2 parents. In a tree, there's a condition where you have only 1 parent. Hello Nitish, how are you? So Dheeraj, you should probably practice more. Like, I don't know your situation completely, so I can't answer. Yep. So in this, let's just calculate the longest path here. We can see that the longest path is this 1, 2, 3, 4. Another longest path 1, 2, 3, 4. The answer for this is 4. We need to print the number 4 for this graph. All right, let's first label these nodes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Awesome. So, starting with the numbers of the first 1 to 9, there are about 10 nodes. Great. Now what? Now you want to find the longest path. Like, if you don't know any algorithm, this might seem a bit hard, but no worries, we'll solve it with dynamic programming. But before getting to that, let's look at the problem first. So the path has to start somewhere, correct? It has to start somewhere. Now, if it starts at 8, it can't go anywhere. So the longest path starting from 8 is just 0, right? Okay, now let's look at 7. The longest path starting from 7 is again 0 because it can't go anywhere. Awesome. The longest path starting at 6 is basically, it can go to 7, right? It can go to 7. All right, so it's 1. Longest path starting at, say, 10. It can't go anywhere. It is 0. The longest path starting at 10. The longest path starting at 9. It can go to 10, so the answer is 1. Now let's look at 5. The longest path starting at 5. 5 can either go to 6 or 5 can go to 7. So it's either 0 plus 1 or 1 plus 1. So every edge is basically plus 1, right? And since we need the longest path, we can either go to 7 directly or we can go to 6 and then the longest path from 6. So the answer for this would be 1 plus 1, 2. Now 4. 4 can go to 7 or 8. There's only one option, like as in there's only one longest path, as in there are two longest paths, but the length is basically unique, right? So 1. It can go here or here. Now let's look at 2. Let's look at this node. Oh, before that, let's look at this node actually, 3, right? 3. 3 can go to 9 or it can go to 10 directly. So, but the longer path would be if you go to 9, isn't it? So 3 would be 1 plus 1. It's basically 2. Now 2, the node 2. 2 can go to 5, in which case 2 can go to 4. If you go to 4, the longest path would simply be, what do you say, 1 plus 1. Or it can go to 5, in which case it will be 2 plus 1. Like longest path from 2, it's simply the maximum of longest paths from 4, or longest path from 5, or longest path from 3. And maximum of all of this plus 1, right? So either 1 plus 1 or 2 plus 1, or in this case 2 plus 1. So longest path starting from 2 is basically 2 plus 1 is 3. Now you're at the root node now. You're at the root node. Longest path starting from 1. So from 1 you can either go to 2 or you can go to 3. 2 or 3. If you go to 2, what is the longest path? It's 3 plus 1. If you go to 3, what is the longest path? It's 2 plus 1. So if you have a long path from this, why would you take this? You'd always take this. So 3 plus 1 is 4. 4. So 4 is the answer that we need to print. Answer. I don't know why I can't write a single simple number easily. 4. 4 is what you need to print. Alright. Is that clear? Any doubts with this solution so far? Any doubts with the solution so far? Any doubts with the solution so far? Clear? Awesome. Aniket, you don't need to do bottom up either. Bottom up is not necessarily required. We can do a recursive approach as well. I'll show you how. All right. Awesome. Now, but how do we store like what's underneath it? So basically, answer for a node. Okay, wait. Basically, answer for a node. Answer for a node. Answer ending at x. Answer of ending at n. A node n is equal to 1 plus max of, answer of child 1 all right, simple, right? Answer of a node, answer ending at, like if you're ending at, or if you're starting at a node, a given node n, answer is basically 1 plus, you can either go from here or from here or from here. Now we can just like recursively, now we have a smaller problem because there are no cycles. If there were cycles, there would be an issue. You would have an infinitely long path. Since there are no cycles, you do 1 plus each of the nodes, like you have multiple nodes, you can choose to go, you can either choose to go here, from here, or here, or here, and so on, like multiple children. And now the answer starting from this node, we'll We'll have them stored, right? We'll have them stored. And now maximum of all these answers plus 1 is the answer for this. And now the answer for the whole DAG is basically the maximum of all answers, right? Like you can start from any of the nodes and you take the maximum of all answers. Here you don't need to know what the root is and all that. Okay. Awesome. Awesome. So I can get to coding here. I shall get to coding here then. First of all, are there any doubts in the solution? Oh, thanks, Sridhar. Awesome. I shall get to coding here then. First of all, how am I going to store things here? Let's look at the input first. Input format. N, M, and there are M pairs. Awesome. So what I'm doing here is vector, vectors. I'm just storing the go-to or like just storing the graph basically. Int n comma m. Now I need to initialize this vector, right? Resize n. Now for int there are m edges. Int x comma y. Take the input. Since the numbers are 1 indexed, I'm converting to 0 indexing. Like the numbers are from 1 to n. Since it's convenient to store, what do you say? Store it in 0 indexing. I'm gonna reduce them. Meaning x to y. Now g of x dot pushback y. So note that this is a vector of vectors. Like each vector is going to be the xth vector. The xth vector is going to be. It's going to contain all nodes that are that x can go to. Meaning like g of x as say x can go to. I'll tell you why it's going to be useful later. All right. Now see now int answer equals 0. Initialize the answer with 0, longest path. For int I equals 0, I less than n, I plus plus. Longest path equals max of longest path, comma, solve of I. I'll tell you one sec. No worries. See out longest path. This is how our solution is going to look. Now I'll tell you how solve is going to contain. Int solve node. For int children, child in G, int best equals 0, best equals max of best comma solve of child, return 1 plus best. Note that if a graph has no cycles, this will exit on its own, right? This will exit on its own. Why? This will exit on its own. Why? Because if a graph has no cycles, there's going to be at least one node which doesn't have any outgoing edge. If the graph has no cycle, it means that there's going to be at least one node with no outgoing edge. Because if it had, like if every node had at least one outgoing edge, then you're going to have a cycle. Because how? We'll try to follow this process. Say we start from one node. We keep going one outgoing edge, then we go to the next node. We can't keep going infinitely. Right? But because if we keep going infinitely, we'll arrive at the same point again. And that would mean you have a cycle. So because of this, every node will not have, like, there would be at least one node without an outgoing edge. And in that case, since g of node contains all outgoing edges, like all nodes that I can go to, my current node can go to another child. All right. So G is basically the adjacency list. G is the adjacency list, as Aniket clearly mentioned. All right. So from the node, you're iterating through all its children. Now you're seeing which is the best children that I can pick, which is the child I can pick, so that I can achieve the maximum path. So I'm taking the maximum of all paths of children, like all the child which will give me the maximum path, and then I'm returning, since now I can go to the child and that will give me the maximum path already. All right, so that's going to be my maximum path, longest path. This is clear, first of all, or do you want me to run it through an example so that it's more clear? I can do any of them. Like, I can run it through an example if it makes it more clear. Note that the order doesn't matter. Like, you can go through any order. Like, for example, in this case, you can one sec. In this case that we looked at, we can ask, we can go in any order. Like, one doesn't have to be at the top. All right. For example, if this was 9 and this was 1, we can compute them separately, like, because you're not storing anything, right? Awesome. So is anything clear? Do you want me to re-explain any part of this? I would please let me know in the live chat and I will re-explain it. Is anything unclear? Thanks, Suraj, about that. Like, yeah, I'm glad to know if it's clear to you. Do you want me to re-explain any part of this? If the edges were valued, then instead of if the edges were valued, I'll just write, like, Aniket is asking what if the edges were valued. Now, here just like you iterate when in the edges, like you write pair of income int edges. I'm just writing it here. Edges dot first. Let's say edges dot first is the node. We just write this. Simple. That's very simple. Like, basically, you're taking maximum of, you can take that edge plus what is the best you can go to. You're taking the maximum of all such edges that you can traverse. The best possible, you're taking the maximum. This is the edge weight. Child comma weight. All right. This would be if edges were weighted, but since they're not weighted here, you can also write it as this. Instead of 1 plus, you can write it here as 1 plus best. 1 plus solve of since you're taking that node, go into that node, go into the child. This would be the correct approach. All right. You can do this. This is actually in the previous question. If you're at the leaf node, depending on what the question asks, if it's the edges traversed, then the answer for the leaf node would be 0. All right. Awesome. You can also write the base case would be g of node dot empty. That means you can't go for any further down. Return 0. But you don't need to write this base case, because if g of node is empty, you won't go any of this. Like, you won't call any other. You won't call the same function again. It directly returns 0, right? Awesome. Redundant. But what is the complexity of this? What's the complexity of this? Can anyone tell me? What is the complexity of this? Yes, similar to DFS solution. You might think this is linear of any sort, but it isn't. It is exponential. It is exponential. Nope, it's not child nodes, it's exponential. I'll tell you why. I'll tell you why it's exponential. I'll give you an example case why it's exponential. This is exponential. Why? Let's look at this case. Let's look at this case. Oh, sorry about that, Hiron. You can subscribe to this channel. Okay. You can follow Telegram for live updates. Hiron mentioned he just joined now. Okay. All right. So look at this example. Look at this example. So Justin, the question is basically the longest path given a directed acyclic graph. Find what's the longest path in the directed acyclic graph. All right. Look at this graph. Now, answer of 1. Let's call this node 1. Answer of 1. Answer of 1 would call answer of 2. Answer of 3. This is basically 3, 4, 5, 6, 7, 8, 9, 10, 11. Answer of 1 would call answer of 2 and answer of 3. Answer of 2 would call, sorry, oh, this is 3 and 4. Okay, sorry, oopsie. Oh, it's far. It's far. The node is far. I said far. Okay. Let's go. Let's call the last node 3. Last node 2. 1 to 2 you want to reach. Okay. Let's check this first. Awesome. Now, answer of 1 is basically answer of 3. It calls answer of 3 and answer of 4. Answer of 3 calls answer of 5 and answer of 6. This also calls answer of 5 and answer of 6. And similarly, this calls 7 and 8. This also calls 7 and 8. 7, 8. Again, this calls 7, 8. This is a binary tree, if you look at it. And but the depth is about O of n, right? O of n by 2-ish. So if the graph is of this structure, the complexity would simply be the size of the binary tree. And the height of the binary tree would be n by 2. Because there's a lot of overlapping here. 8 is being called again and again here, if you look at it closely. So it could be up to 2 power n by 2, right? It could be up to 2 power n by 2, the complexity. So it's not favorable. It's exponential. Why is it exponential? And you might say this might seem like DFS, but why is it exponential? Because we didn't mark anything visited here. We didn't mark it visited. So we're going to each node multiple times and we're going through it sub-3 multiple times recursively, and that's what's making it exponential, right? So we know that the answer of a node is going to remain same if you call it from one node or the other node. Like if you want to call it from, if you want to find the answer of 5, it's going to be the same whether you call it from 3 or 4. The answer of 5 depends on what's underneath it. It doesn't depend on who's going to call it, right? Yes, Aniket's right. We can store the maximum longest path for an already traversed node. That's perfect. You got it. So we declare another DP dot resize n, but we declare it with -1, saying that now if DP of node not equal to -1, return DP of node. This is clear. That's it. That is going to make our problem from n squared to O of n. Why? Because O of n plus m, sorry. That's going to make our problem from exponential to O of n plus m. Why? I'll tell you why. So basically what's happening here when you're storing it, like basically what I'm doing here is I'm initializing all of them to -1. Oh wait, I made a small mistake here. DP of node. I need to, like, whenever I'm computing it, I need to store it inside DP of value as well, right? DP of node. That's a mistake. Again, anyway, that's a small thing. So what do we have here? So once we are computing all of it, we can write this is O1, so we don't need to really write it here, but I'll just write it here so that it's convenient. Awesome. So what do we have here? When we're computing it for a node, say the very first time we're computing it, we compute it again, and then once we compute it, it took us a while to compute it, but that's okay. As long as we store it. Once we store it, we make sure to never compute it again. How are we making sure that since we're initializing all of them with -1, and the longest path is going to be at least 0. So that's the reason we are initializing it with -1. All right, initializing it with 0. And now what does this mean? It means that we have computed a value. If it's not equal to -1, it means that it's been overridden with some good value. And the only thing it's being overridden is with the answer of dp of node is basically the longest path starting from node. Awesome. Is this clear so far? So how does it look in a graph? So basically, when we call answer of 1, it computes answer of 3, and answer of 4. Similarly, this asks downwards. So the last answer would be 0. And answer of 9 would be answer of 0 plus 1. 1. Answer of 9 would be 10 would be 1. Answer of 8 would be max of 9 and 10 plus 1, which is 2. This will also be 2, 3, 3, 4, 4, then 5 in the end. All right. So basically, we reduce it to a smaller problem, which is basically a different node in the graph, a lower node in the graph. Once we know the lower node, we have the answer for the higher node, and so on. So now we have all the answers starting from each node. We know at which point we need to you know the answer, which is basically the max of all the answers. Is this clear? Any doubts with this so far? Any doubts? Do you want me to re-explain any part of it, or the complexity if the complexity is not clear? Note that for every edge, we are traversing exactly once. For every edge here, this is basically every edge. We are traversing exactly once. We are traversing exactly once, right? Aren't we? We're traversing for each edge exactly once, meaning you're not coming to this edge again, because to come to this edge, we need to come to node first, right? But we're coming to node exactly once, because once we come to that node once, we are already computing it again, and we're returning it here the next time we come to that node. All right. Okay. Sorry, I'm gonna get, yeah. Awesome. Is this clear? Is this clear? Is this clear? The people in the chat, like, are there any doubts? Is there anything you'd want me to re-explain? Any doubts so far? Awesome, awesome. 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 I guess if this is clear, then now you know you've solved a decent difficulty graph problem, like if you're a beginner. So I hope you got the idea about this. So basically what I did was, initially you had a graph. There was a graph. Like for those who've come new, I'll just briefly explain what I did here. So initially the question asked, given a directed graph n vertices and m edges, the vertices are numbered from 1 to n, and for each I, the I directed edge goes from vertex xi to yi. And the graph does not contain any directed cycles. You need to find the longest directed path in G. All right. Now we had a directed path. What did we do here? We found that, like, first we figured how to, like, store the edges. and in what way if we store the edges, we can complete the answer easily. And how did we do that? So first we try to figure out the solution. Like given the graph, how would we figure out the solution? Like we tried out sample cases, we tried out different cases. We tried out a decently sized case like n equals 8 or something. And from that, we figured out that like we can start at the base, and for each node, we can find what is the longest path starting at this node. All right, and how do we find that? The longest path starting at a node, it's basically 1 plus, like you have a bunch of nodes underneath you, like you can go to a bunch of nodes. So for each node, we calculate what the longest path starting from them is. Like what if the longest path starts from each of the children, what is the longest path? And now we take the maximum of all those paths, and now there's the node, say there's the node whose longest path is like, starting from that node is like 100 and the other nodes are like 5 or 20 or something. Now say this node, you go to this node instead. Like why do you want to go to that node if this achieves you if this gives you the longest path, right? Now that this gives you the longest path, you take this node, and basically your answer for my current node is basically 1 plus maximum of all the maximum of all the answers of my child, right? And the answer is basically the longest path starting from that child. Now recursively, I keep doing it layer by layer until I reach the end. And then once I find the answer, I keep returning it upwards. And in the end, now I have the final answer ending starting at this node, like number of longest paths, the maximum longest path starting at this node. All right. Awesome. Now I'll get to the code. Like what do I do in the code again? First, I took the input. I initialized DP because I wanted to store it, but I'll get to that. I'll get to that later. Now, int x and y. Like basically these are the edges. Now x minus minus, y minus minus, because I wanted to subtract 1 from them, so that I wanted to like make it 0 indexing so that it's more convenient to calculate answers. Now longest path. Now what does solve I represent? This computes the longest path. All right. Awesome. Now, basically, if I have no nodes, then just return 0, right? Return 0. There are no nodes underneath me. That means I can't go anywhere, meaning the longest path starting from my node is 0. Now, for each child, I calculate what is the best possible. What do you say? The longest possible path I can go from child. The longest possible path I can go from child. Right. It's basically that. And then once I know the longest possible, like 1 plus longest, you take maximum for over all childs. You can add 1 in the end also, whichever is more convenient for you. All right. Is this clear? Any doubts so far with this? I'll explain another answer, another solution, like another question, a tiny modification of this question. Say you want to find the number of what do you say? Count of paths starting from the node 0. Modulo 10 power 9 plus 7. Count number of paths. Or not, forget the modulo. Count of paths. So you just want to find the number of count of paths. This is a slight modification of count of paths starting from 0. Where is starting node is 0. How would you do this? It's very simple. What? Answer. So we just recursively answer this question. How do you do that? So again, for the question is basically one sec. Fine. In a graph, in a DAG, count of all. It's very similar. The problem is very similar. I'd like you to, like, if you're there in the live chat, please let me know what you think of the solution. So previously we did count of a given node is equal to 1 plus max of, longest path of a given node is basically 1 plus max of longest paths of the child. Now, how do you count all the paths in the DAG starting at at node 1, or if you're taking 0 index, node 0. How would we do this? How would we do this? How would you represent it in smaller terms? How would you represent it in smaller terms? How would you represent the number of counter paths starting at a node in smaller terms? Yes, exactly. For each child, you compute the answer and you sum up the answer for all nodes. Right. Yes, Aniket. So basically, we want to calculate. Yeah, we start traversing from 1 only. So answer of 1. So we have multiple choices here. We have multiple choices. We can either go to child 1. The path can go like, for example, 1, 2, 3, 4, 5, 6. The number of paths from 1 is basically number of paths from 2 plus number of paths from 3 plus number of paths from 4. Answer of 2 plus answer of 3 plus answer of 4. Now answer of 2 is basically answer of 5 plus answer of 6. Answer of 3 is basically answer of 6. Answer of 4 is basically answer of 6 again. So that's it. And answer of a child node, which is 6, if there are no outgoing edges, the answer for that node is basically 1. So if we keep traversing the child down and down, if you keep going down, we're going to reach an end node, and that's when we return 1. So the count is basically, everything is going to remain the same. See out, solve, 0. It's not, nothing's going to change here. If it's a child node, then you have 1 path. It's an empty path. That's the base case. It's important to know what the base case is. Now, let's compute the answer. Answer plus equals solve of child. That's it. For a lot of dark questions where DP is involved, the format is going to look similar. So you add it over the children, and for each of the child, you either take the max. Previous you took the max, now you took the sum, and you change the base case. That's the only difference. Is that clear? Is that clear? Any doubts on the solution? Do you want me to re-explain this? I will re-explain it if you want. Is this clear? Yes. Awesome. Is this clear? Any doubts in the solution? Would you like me to re-explain some part of it? Awesome. Awesome. Is this clear, everyone? People in the live chat, can you just let me know if it's. Do you want me to re-explain this part? Like, I will re-explain it. Like, if you want. I didn't clearly explain it because I thought that it was very similar to the last problem. But if you really want me to explain it, I would. If there's any part of this which is unclear, this is basically summing over the answers for all children, right? It's basically summing over the answer for all children. Answers for all children, and for the basic leaf node, the answer is going to be 1. There's an empty path, but it's some path. And this 1 is being added up over multiple times over here. And then in the end, you get the number of paths. Usually, if n is huge, the answer is going to be big. So they're probably going to ask you like, print the answer modulo 10 power 9 plus 7 or something like that. Because we just saw that there are exponential possible paths, right? When we did in the previous problem, when we didn't show the answer. So that's going to be reflected here. That's it. here on, I'm gonna complete harder Atcoder DP problems in the series. I do plan to, but I'll see like if I think it's right for you to teach, then I will teach it to you. Yes. And given I have time, yep, I will attempt to teach it. Yes. This is clear so far. Awesome. And please don't call me sir. Awesome. Yes, I do plan to discuss more and more problems, and I would like, and if you just started with DP and if you're struggling with it, I will try my best to give you the intuition of the problems as well, like how the essence of the problem and what's so cool about the problem and so on. Look, you did this problem without Bellman Ford, and you can also count the number of paths, all the possible paths, which seems so overwhelming without dynamic programming, like without actually, if you don't reduce it to a subproblem, it might seem a bit overwhelming, but once you know the practice, once you know like what the concept is behind it, like just reduce it to a smaller problem. That's what DP is all about. Most of DP is about this. So, all right, any doubts? Guess we can end the class then. So before ending the class, I'll just let you know about, there's this Telegram channel where you can get live updates on the latest classes. So if you don't want to miss out on any classes, do install Telegram if you haven't, and subscribe and join this class. And if you think you found this video useful, please do drop a like. And if there's anything you think I can improve, please let me know in the live chat. I'd be happy to incorporate that. And please do share it with your friends if they've just started. It's going to be useful. As it said, like knowledge is best when shared. And if you haven't subscribed already, please do subscribe if you want more and more content of this class. Aniket mentions he has not solved a lot of DP problems. He has solved a lot of DP problems, but I'm still not confident about it. I don't think you can ever be confident about DP because DP is a really vast topic. The more you solve, even I'm not confident about DP, so I can't suggest a roadmap. But so one thing I could suggest is, like, when you're solving a DP problem, don't think of it as, hey, there's a table over here and I need to go from this cell to this cell and so on. There's a DP table. Think about it in terms of states and how we can reduce it to smaller problems. Every DP problem usually has a smaller problem associated with it, like a bigger problem in terms of smaller problems. Even though it's not given the editorial, try to find it from the editorial, or try to come up with it on your own after reading the editorial. That will help you. That will help you come up with, like, that will help you develop your recursive thinking skills. Again, as I said, I'm not very confident about it either, so I won't be the best person here. So yes, writing DP code, of course, it takes time to think. It takes time to think for me as well. Like, you need to be really careful. You can't afford to miss any plus or minus one anywhere. That's with any code, but in DP there are lots of, like, pluses and minus ones here. You might hit, you might miss, but. So Crimson asking, is it necessary to provide a bottom-up solution every time? No, I just provided it so that it's easier to understand for you guys and girls. Yeah. Awesome then. I guess I'll end the class then. And yeah, I have a few commitments after this, so I can't really extend the class too much. Awesome, man. See you and have a nice day. And if you have any doubts, please do drop them in the comment section. I usually look at the comment section.